Aloha, Richard Halverson here. This is ITS128. Let me just check to make sure. Yes. Today is October 5th. And let me share my screen. Uh, 128. And we are in this right here, right in here in chapter 5. And last time I just do this every time just so you can see how you do this. I go down here and I see we did chapters 5.1 and 5.2. And so that's this. And oops. So here we can see we covered 5.2 by looking right up here. And when we go here, we see we did the 5.14 lab. All right, so that's where we are. Let's continue on from there. Let's go to the textbook. And go to loops. And so I think I'll probably, talk some more about loops here, and maybe after that I'll go to, let's see, after we're going to do loops, and then we're going to do for loops. And so I can see 514 was a while loop. And 516 is also a while loop. So why don't I do 516 also? As soon as I'm done with 3 and 4, I guess. All right, so we're talking about while loops, and you remember a while loop is this is the block, the indented part, down to where it's not indented anymore. So 8 through 11 is the indented block that's executed 0 or more times, and whether or not it's executed depends on what the evaluation of this condition is. And so this is either going to be true or false. If it's true, then this block executes. This block executes, and then we come back and we evaluate this again. And so we need to make sure that this evaluation is going to be different. Eventually, that this evaluation is going to end up being false, because only when this evaluation is false do we stop iterating through the loop. Okay. So this happens to be a greatest common divisor program, and the way the program works is you can figure out what the greatest common divisor is between two numbers by keeping on subtracting the smallest number from the biggest number and have that be the new number. And you keep on doing that until the two numbers are the same. Here we can see how this works. So if we run this, this is a pretty simple one, because you just 20 minus 15. See, so this has a value and this has a value, and then while they're different, if A is bigger than B, then subtract B from A, and then you loop again, and you keep on doing this until while this is false, you keep on doing this until this is true. Well, you can see that it's hard to see the loop work. It's easier to see the loop work if we put some print statements in here. So I'm going to put a print statement in here, and I'm going to say num a equals comma, and then I'm going to print out num a, and then I'm also going to down here, since num b is what changes, I'm going to do print num b equals comma num b. Okay, so when this loop executes, if this is taken, if this executes, which means that num a was greater than num b, then we'll see what the new num a value is. And each time this executes, we'll either see this printout or we'll see this printout, and it'll keep on executing until this is equal, in which case this will be the greatest common divisor. Now, keep in mind, this is equal to this, so it doesn't matter if we output num a or num b. But so let's run this now and see what it looks like. Well, num a starts out being 20, num b starts out being 15. So the first time this executes, num a is bigger than num b, so num a gets updated, and then the next time num b gets updated and num b gets updated, and the final value is this. If let's try 51 and 169. Okay, so if we run this, we start out subtracting. This is a, so then b is bigger, so 169 minus 51 is 118, and then we keep on subtracting until we end up with 51. Oh, I meant 52. So here the greatest common divisor is 1, which means that these are what's called relatively prime. But if we do 52, I was looking for 16, no, 13. Here, 13 is the greatest common divisor. It goes in the 52 4 times, and it goes into 169 13 times. So anyway, this is just a demonstration of a loop, and this is a pretty common little algorithm to demonstrate all kinds of things. We're going to see this greatest common divisor algorithm more than just this time. We're going to see it when we look at recursion and all that. Okay, so this is a program which has a while loop, and it looks like it uses the random number generator, or the random number module, library module. And what this is going to do is it's going to grab a random number here. We use the random class, and this will return a random number between 0 and 2. So that's what that's going to be. And we see if the random number equals 0, then we're going to print this out. If the random number is equal to 1, we're going to print this out. Oh, it's going to be just an integer. If the random number is a 2, then it's going to print this out. Otherwise, it's going to print this out, and it should never print this out because it should only be 0, 1, or 2. So this is just if there's, this should never happen. But anyway, so if we run this dumb little program, it just tell me something about yourself, and so what is input is tell me something about yourself. Thank you very much, Mr. Robot. I guess I'm not sure what we're supposed to get out of this. Import this, print this, print this. And then the input was nothing, so I'm not sure what this is. I am a person. I don't know what this is. So anyway, oh, it just loops until I say goodbye. I see what this is. Whatever. Okay, so this tests your understanding of which if else branch will execute when the user types goodbye. So it just tests your understanding of this. Which if else branch will execute? Well, if the user types goodbye, then this is going to be false because the user actually did type goodbye. And no if then else, it should be none, because the if else branches don't execute, because if the user types goodbye, then none of these execute. Okay, we skip out. So the answer should be none, I believe. Yes. Okay, how many times does the loop iterate in the program? How many times does the loop iterate? I don't know what the answer is. I'm going to see. Press the answer again. Answer unknown. The loop will iterate until the user types goodbye. Is unknown an answer I can say? Oh. Okay, all right. So anyway, that's the answer, right? Because it doesn't. It depends on what the input is. So anyway, you can make sure you understand that. Getting input until the sentinel is seen. Okay, so in this example, we are reading in a bunch of things, and we're going to read until we get what we're going to define as a sentinel value, which is an ending value, and we're going to define that ending value is 0. Okay, so when somebody enters in 0, then that means that's the sentinel value, and that means to stop. And so that's how this works. See, while the current value is great, it reads in a current value. It's got to be greater than 0. Actually, it's 0 or less, so it can be -1. But as long as it's positive, it continues. But 0 or less than 0 is a sentinel. All right. So how many actual non-sentinel values are given in the first input sequence? Is that this? 1, 2, 3, 4. I guess it's 4. For the given input sequence, what is the final value of num values? Well, what is num values? We're adding them up, huh? Okay, so starts out with 0, and then we just add them up. 10, 11, 17, 20. Num values is how many values. Each time the loop executes, we increment num values by 1. So it's starts out 0. Okay, yeah. So it's 1, 2, 3, 4. Yeah. All right, so make sure you understand that. Okay, here's the challenge activity. While loop with sentinel. Let's run it. Okay, so the current value is it reads in a current value. And then it sets the minimum, it sets this variable called min number to that current value. So min number is now going to equal 2. Then it's going to go while the current value is greater than 0. If the current value is less than min number, then set the min number variable equal to that value. So this program keeps track of the minimum value that's read in. Keeps on reading values. Each time it reads a new value, it stores it in this cur value variable. And as long as the cur value variable is greater than 0, then it does this test to see if we have a new minimum. So at the end, we're going to print out the minimum value that we get. And it's going to be the minimum of this one and this one and this one. And so the minimum value looks like it's 2. And it doesn't print a return. it prints out min space value colon 2, just like that. No, it's going to be a space. There's going to be a space there. Because there's a space. It's a comma here. There's going to be space between the two. All right, let's see what this is. Yes. Very good. Okay, we can do the next one. This one is, this is another Sentinel one. The Sentinel is -1, current values. So it's going to start out with the final product. Okay, so we're going to be multiplying these together. So we start out with 1, and then we're going to read these curve values until we get the Sentinel. And so each time we're going to multiply the final product with the curve value. And so the first time it's going to be 1 times 2 is 2, 2 times 4 is 8, times 3 is 24. So it should be product colon space 24. Yes. Okay, you can do the last one. Here's another one. Write an expression that continues to bid until the user enters an AND. So write an expression. So this is where we write an expression. And it's going to be until so we have to put something here. Okay, so it's keep bidding is the variable, and we initialize it to a hyphen, I guess, or whatever that is. It's not an and though. And then we loop while keep bidding. While keep bidding is not equal to and. While it's not equal to and, then we want to loop. So until the user types in an and, this thing loops. So that's probably what this is probably what the answer is. All right. So what's the next one here? I won't do the whole thing. I'll just make sure you understand what they're asking. Given positive integer this number of insects, write a loop that prints then doubles num insects each iteration. Print values less than 100. Okay, so we're going to start out by you read in some number, and then you're going to print out. You're going to have a loop which doubles that number, continues to double the number until the number gets bigger than 100. So you're looping. So you're going to have a while something, then you just do that, right? And then the next thing is going to be it's got a it prints then doubles. It write a loop that prints. First it prints print num insects somehow, and then you double num insects double it equals num insects plus num insects, or something like that. However you want to double it. A couple of ways you can double it. Okay, so that doubles it. And then you got to put in a while loop here. And so each time it prints out, and it's going to print out while the thing you're printing is less than or equal to 100. So you should try putting in, 25, because that will hit just exactly at 100. You can try hitting, yeah, try that. That one can't do 99 or 101 because you're doubling, and there's no integer number that you can double and it'll be 99 or 101. Anyway, so you can fix that. So that's this challenge activity. All right, counting. So counting with a while loop. Commonly, a loop should iterate a specific number of times. The programmer can use the variable to count the number of iterations. And so, yeah, we have something like this here where we're going to execute this loop here, whatever it is, until n reaches a particular value. So inside here, and you start out with 1. So inside the loop, you better have something that increments this thing that you're testing, where you're counting the number of iterations. That's all. A common error is to forget to include this. Common error. Well, you only make the mistake once because you run your program and you're sitting there waiting for it to be done, and it never finishes. And then, boom, there's an error that says you took up too much time. And that's because you never incremented. This thing just keeps on looping forever. All right, so what does this do? Following program outputs the amount of money in a savings account each year for the user entered number of years, with this being this initial savings and 5% being the yearly interest. A long time ago, savings accounts used to give this kind of interest rate. Have you seen what the interest rate is now for a savings account at a bank? It's like 0.05%. Okay, it's nothing. I can't believe it. Anyway, so these are kind of dumb examples. So they should do something. Anyway, some investment or something. You've got a money market, mutual fund that averages 5% yearly a year or something. Anyway, so let's do this one though. So we're going to run this, and we start out printing out what our initial savings is, and then each year we're going to add this amount to it. So each year we're going to take this, we're going to take whatever the amount is, multiply it by 0.05, and that'll give us some small number. Like the first time, it'll give us $500, I guess, and then that gets added to the savings. And then the next time around, you take 0.05 times 10500, and then you get another number. And so that's what we're doing here, and we're entering in the number of years. And so this is going to loop for that number of years. So let's so if we run this and we say 10, let's say 2 years. Okay, so we just say 2 years, and we're only going to get this amount because the first year is this, and then just the next year we take, it's this interest rate times this initial value, and that's why we get that. But if we keep going and we go to 3, then it's a little bit more. Oh, here it shows. Okay, so, and then if we go to 10, of course, it's all the way like this. So you can see that this 5% added at the beginning only gives us $500, but 5% added in the 10th year gives us whatever this minus this is, which is it's a larger amount. It's $800 or something. So anyway, and you can see that there's this incrementing thing. So each time we print this out for the year, see that this is the first one, and then we add and we increment and come back around, And so at the very end, savings is going to equal something that's bigger than this because we never really print the last one. We print the second to the last one. See, look, let's go. Let's do this. Let's print print savings. It's going to be bigger. See, this is the last one, but then really savings gets added to one more time, and it's the very end of savings is really this. See, so anyway, so make sure you understand what this the program. Use this in each answer. Loop iterates 10 times while I is less than or equal to 10. Yes. Okay. Loop 99 times. While I is less than or equal to 99. Iterate 2 times. While I is less than or equal to 2. Boy, those are really hard. All right, other forms of counting. This here we're counting down. 5 down to 1. Here we're counting every other one where we're incrementing by 2. So this is only going to loop 50 times. Write a program that prints the U.S. presidential years from this day all the way up to present day, knowing this. The current year is 2021, and while the year is less than or equal to current year, then print the year and increment the year by 4. Wow, what do you know? Nice. All right, the loop iterates over the odd integers from 1 to 9 inclusive. So what's the loop body? I plus 2. Does that work? 2. Yes. Loop iterates over multiples of 5 from 0 to 1000. I is less than or equal to I guess it inclusive. Okay, yeah, so I guess it's this. All right, so make sure you can do those. Participation activity. What are we supposed to do here? Write. Okay. All right, well, that's interesting. What am I supposed to do? I equals 1. I equals less than or equal to. What am I supposed to do? Am I supposed to do these? Uh, 0 to 10,000. Well, I equals less than or equal to 10,000. I equals I plus 500. Oh, I gotta go like this. Plus 500. 500. Yes, nice. Oh, 0. Okay, so anyway, you can, oh, this is factorial. You can, and so in this problem here, we are writing a program that lets the user enter a value, and then the program computes the factorial of this number, and the factorial of this number is this number times 4 times 3 times 2 times 1. So it's 5 times 4 times 3 times 2 times 1. Actually, we don't need the times 1 because anything times 1 is itself. So we're supposed to modify this program or finish this program so it finishes our. So for example, when we enter 5, it'll output 120. Okay, so here we're reading in the number that we're going to factorialize, and we're going to start out with setting this number total. So I think the way we're going to have to do it here is it's, so this is going to be the computation of total when it's all done. So we start out by setting total equal to n, and then we multiply it by n minus 1, and then multiply it by n minus 2 all the way down to 1. So we start out by setting total equal to n, and then it looks like we have this loop variable I, which I presume is going to iterate. Here we decrement it. Here we take the total and we multiply that total by I. So I the first time we iterate through here, that's not really how you should say it. The first pass, I is going to equal n minus 1. So that must mean that I equals n minus 1. And then while I is great, okay, so this is going to be I equals I minus 1. Because we're decrementing I, lowercase, caps lock off. I equals I minus 1. And here we're setting total. This is total. This is total. So let's just take advantage of the fact that we got this here, and we'll turn this into an equal sign, and we can just leave that. No, we can have parentheses around the I. That's fine. And so what this is, and then we're decrementing. So while I is greater than 1, we don't want it to go all the way down to 0, because if you multiply it by 0, it's going to make it 0. So while I is greater than 1, so the last pass through here, I will equal 2, which is fine. We don't have to have it go all the way down to 1, because anything times. So let's see if this works. This might work just off the top here. Oh, there it is, 20. Okay, so let's try 8. They give us 8. Oh, that's nice. What's 4? All right, well, it looks like this works. Okay, so that's an example. Calculate factorial. All right, shorthand operators. This just says, you notice here we did this like this. We wouldn't have to. We can do shorthand and do minus equals. See, that's the same thing. Here. So we can do any arithmetic operator followed by an equal sign, and that's like taking whatever is on the left, and that's the operand. That's the first operand on the right. So this is I equals I plus 1. So write a statement using this that doubles the value of a variable this. So that's simply that this doubles it, huh? I guess that'd be 2. You know, I wonder if this would work. You could do plus equals my var. I don't think it's gonna accept it. Because that would double it also, wouldn't it? Okay, no, we're supposed to use this. Okay, so anyway, write a statement using this that is equivalent to this. So it would be my var plus equals this. I think, yes. Okay, very good. All right, here's a challenge activity. I'll do one of them. Did I do these? No, I didn't. Okay. Loops with variables that count. Okay, there's loops that variables that don't count, ones that count, I guess. So let's start. What am I supposed to do? Write the output. N equals 1. While n is less than or equal to 3, print this and then add 1 to it. So this is going to iterate where n equals 1 and n equals 2 and n equals 3. So there's going to be 3 iterations, and each time n is 1, 2, and 3. So it's going to print 3, 4, and 5, I believe. 3, 4, and 5. Because the first time n is equal to 1 and n plus 2 is 3, so it prints that. N is incremented, comes back around, and anyway, so let's see if this is the answer. Ah, yes, nice, great. So you can do the next one. While loop, print 1 to n. Oh, this is a challenge activity. Okay, great. Write a while loop that prints from 1 to user num, increasing each. Okay, well, this looks like a tough one. While I is less than or equal to user num, then print I and then increment it. Yep, boy, that sure was easy. All right, what's this one? I'll try not to give you all the answers this time, the whole answer. Retype or copy and then run the following code. Note incorrect behavior. Then fix the errors in the code, which should print num stars asterisks. It should print num stars asterisks. So it should print however many or whatever num stars is. That's how many asterisks it should print. So I guess this doesn't work. Okay. And it doesn't work because it's just gonna iterate forever. Because okay, if it iterates once, it's going to iterate forever because there's nothing inside the loop that changes either of these. So whatever these are the first time, they're the same throughout. So you read it in num stars. Oh, and num parameters equals 0. Yeah, okay, so what we need to do is increment num star, increment num printed. So you need to increment num printed each time you print a star. So you have to have num printed equals num printed plus 1 someplace inside the loop, and that's going to change this until and you can it'll keep on changing it until it reaches this, because when this reaches this, then this statement will be false, because num printed will be equal to num stars, and that will cause the loop to stop at num stars. And it might be off by 1. No, okay. So you also could be off by 1, and you're going to have to test to make sure that that's not the case. It's possible you might have to end up changing this. But anyway, I'll let you work on that one. Let's see. I'm going to see. Oh, yeah, I don't want to. I'll tell you what I'll do. I'll just copy it over here. Copy this, and I'm going to put it over here. This is my test. It's called test 2. And when I run this, and so I'm thinking it's something like, if I increment it here, num printed, then as soon as it's not equal, or as soon as it's equal, it's not going to print this. I think we might be, this might be off by 1. I'm not sure. Enter number of asterisks. Okay, so let's see what this happens on. Let's see what happens when I run this. I'm going to do Python. I just need to do, yeah, okay. Python test. This is test2.py, I guess. Number of asterisks to print 5, and it prints 5 asterisks. Oh, okay, well, all right. That was easy. Let's move on to the next one here. For loops. All right, for loops are okay. So we learned about while loops, and it turns out that while loops are all you need. You don't need for loops, but for loops offer such convenience, because oftentimes you're iterating through something from the beginning to the end, or you're going from 1 to 10, or something where you specify everything up at the top, and then you don't have to worry about having some sort of incrementing thing to make sure that you don't end up in a. So you make sure you don't end up in an infinite loop. Okay, so for loops are shortcuts, and there's a lot of different varieties of them, and we'll go over those now. Okay, a basic for loop is you have the word for, and then you have a variable, some identifier variable like name or something, and then you have for each thing in here. And so container is going to be something like, it can be a list, or it can be a range, just like from 0 to 5, or so 0, 1, 2, 3, 4. Or it can be a dictionary, or anything that you can iterate through. And so this loop will iterate through all of them, and each time this will be equal to the next one, the next one in the container. So here, for example, we're going to say we have a loop, a for loop, for each variable name in this list of variables. Should I make this big? In this list of names, do this. And what this is, it says hi, and then the whatever this is goes right here. So the first time it's going to be Bill, and the second time it'll be Nicole, and the third time it'll be John. It'll be 3 times, 1 for each one. And so it's going to print this out. That's pretty simple. All right, so here we're defining a iterating through dictionaries is a little different, because with dictionaries there's a key and there is a there's a value, there's a key and a value. So so let's say you define a dictionary that looks like this, and it's got 5 entries, and the keys are these 3-letter network, you know, call letters or whatever they're called. And then these are the channels in someplace. And so we're going to loop through these channels, and C is the this thing. It's the key. For each key in here, print the key and then print the value for the key. That's what that is. So we see the first thing that's printed is this, which is this, the C, which is, we're looping through these channels, the first one. So the first one is the key. Yeah. And this one is how you reference the value for this key. For this key. The key is C, whatever C is. And then this is the dictionary channels. And so the channels of C is, you know, the value. So that's how you iterate through a dictionary. Here's how you iterate through a string. So a string can be thought of as an array, an ordered array of or list of characters characters. And so so this works. You're iterating through for each character in the string. You don't have to use this variable name. It can be C or it can be anything. But for each character in the string, this is a character. And here this takes this, each character in the string creates a new string where it takes that character followed by an underscore. And so it would end up looking like this. Whatever. So you're printing that out. Starts out with empty. Okay, so let's see if we understand this. Now, iterate over the given list using a variable called myPet. So for myPet in this set of pets, I guess. Is that right? Yeah. Okay. Anyway, you can do this. Let's do this one here. Iterate the string 911 using a variable called number. So iterate, okay, for number and 911. Is that how you do it? It's like this one. Shouldn't matter what kind of quotes I use. Yes. All right. Calculating shop revenue. Okay, here where it's just an example here. We have a list. See, it's got brackets here, square brackets. Any other language would call this an array, but in Python we call it a list. So it's got these values: 1, 2, 3, 4, 5, 6, 7 values, and 7 elements. So this is going to loop through that list one at a time, starting at the beginning. So the first time this iterates through, day is going to equal this. The next time it's going to equal this, and so on. And we see each time it loops, it adds day to the total. And at the end, we have the we want the average So we take the total and we divide it by the length of this array. So this is a quick way to get the length of the array. It's a method here. So you take the total divided by the number of them and you get an average. And so this outputs it. Notice that it uses this formatting, two digits to the right of the decimal floating point number, 2 digits to the right of the decimal point. Like that. Same here. All right. A for loop may also iterate backwards over a sequence, starting with the last element and ending with the first element by using the reversed function to reverse the order of the elements. So you do something like this. You say, when you're saying what you're going to iterate over, you just use this reverse function here, method in front of, or enclose the iterable in a reversed method argument to this reverse method, and they'll come out in reverse order. Very simple. All right, fill in the missing. Let's do something here. Let's do this one. Assign numreg with the number of below freezing Celsius temperatures in the list. Okay, so we're going to loop through this list and we're going to count up the number of below freezing Celsius temperatures. I'm going to assume these are all Celsius temperatures. So we got 1, 2, 3, 4. It should be 4. So we start out with 0, and for each temperature in temperatures, if temperature is less than 0, then increment numreg, increment it by 1. Oh, it's not numreg, it's numneg. Well, anyway, you can fix that. All right, what's next? Looping over strings, lists, and dictionaries. Okay, so when you loop over strings, you're going 1 character at a time. When you loop over lists, you're going 1 element of the list at a time. And when you're looping through dictionaries, you're going through the keys. There is an order, but you can't really. It's hard to get at the order. It's easy to get at the order. But anyway, when you iterate over dictionaries, you're iterating over using 1 key at a time, and you get at the value by using by indexing the name of the dictionary. So let's see what let's do one here. Okay, type the output. Print color. Okay, these are all strings. So print all the color. Print cyan, red, tan, blue. Oops. Is that it? Simple enough. Yeah. Okay. What's the next one? Characters. What am I going to print? Oh, this is easy. M underscore E underscore M underscore O underscore R underscore Y underscore. And then this. That's what this last print does. That prints a return. I think this is the answer. Yeah, it is. All right. Let's see what this is. Let's see this one. For loop. Printing a list. Write an expression to print each price in stock prices. The sample output with inputs. Oh. All right. Looks like price is what we're getting one at a time. And prices in stock prices. because stock prices looks like it's a list. So this is going to ask the user for something, and this is going to split it up into however many elements using a space as the split as the split character. And so there's 3 of them. And so this is going to create an array or a list of stock prices, 3 elements, 1, 2, 3. This is going to loop through them. So I think this is the answer. Pretty sure this is the answer. You can check that. Let's look at this one. For loop, printing a dictionary. Okay, it looks like we're looping through a dictionary now. Okay, so it's going to have a dictionary of the keys. The keys are the names of the people, and the values are their email addresses. So we are, so what are we supposed to do? Oh, this adds. Well, this adds a new one, doesn't it? Okay, so what am I supposed to do here? I'm supposed to write a solution. Okay, so what this does is, first of all, it initializes a name here, and then it and then it prints it out. Okay, I'll tell you what, I'm gonna copy this over here, and I'm gonna. So I have so first I'm gonna okay, so this adds one more in there, and what happens if I'm just gonna print contact emails. I'm just gonna see what this does. Oh, it's asking me for something. Look at that. It's asking me for something. All right. New contact is going to be Joe Schmo. And the email address is going to be Joe S at Hawaii.edu. I don't know. I'm just making this up. All right, and so then we print it out and we see that Joe Schmo has been added like that. So now what are we supposed to do now? I'm supposed to we're supposed to print out looking like this. Okay, well that's different. I'm gonna say am I supposed to say so? For person in the contact emails. I need both the, oh no, okay, so print contact emails a person. So I'm going to print the contact email first, and then I'm going to say is, and then I'm going to say the name, which is person. Okay. Okay, so let's see what this does. Oh, and I'm going to ask, I'm going to say, enter a name. And I'm going to say, enter email. All right, so I know what's going on. Okay, so I'm going to run this. Okay, enter a name, Alf. Enter email, alf1@hmail.com. Prints out that. That's nice. Okay, well, anyway, so you know enough to finish this challenge activity. What's next? Oh, now we're going to talk about ranges. There's a function called range, and it generates a sequence of whatever you have in as arguments for this method. So this is just going to, so this would just print out, generate a sequence starting with 0 going up to y minus 1. Assuming it's a non-negative integer. For example, this is going to generate the sequence 0, 1, 2. So it doesn't do it starts at 0, but it never does this. So it's 0, 1, 2. See, it's all non-negative integers less than y. And this is going to be x up to, but not including y. See? All the integers greater than or equal to s, but less than y. So it always skips the top one. This is going to go from -7 to -2. No, I'm sorry. -7 to -4. We're going down. No, we're going up. So -7, -6, -5, -4, and it doesn't do -3. Okay, this makes it so we go from here to here, but this is here we're incrementing by this value, or we're skipping. So let's say this was 10 and this were 20 and this were 2, then we'd be doing 10, 12, 14, 16, 18, but not 20. So this were 10 and 20 and 2, it would skip every other one. If it's 5, it would do 10, 15, and then not 20. Incrementing by z, you see. So this is an example. Here is we're going backwards. This is going down, and so the incrementer thing has got to go down. It's got to be negative. So here's some examples. It's all pretty easy. All right, calculate yearly savings. Okay, so initial savings of $10,000. Seems like we've done these before. Initial savings of $10,000, and the interest rate is 5% a year, which is completely absurd right now. Have you ever seen what the interest rates are at banking interest rate today? .1%. So not 5%, but 0.1%. It's just crazy. It's like, why do it anymore? All right. Back when I was in grade school, at my elementary school, we were able to start a savings account, and it was 5%. I remember that. Anyway, so what we're going to do is we're going to iterate over the years, and each year we're going to calculate what 5% is of what we have, and we're going to add it to what we have. So each year we're going to take what we have in savings, we're going to multiply it by this interest rate, and it's going to be like 5% of our savings, and then we're going to add it to our savings, and that's going to be our new savings. So that's what this thing does. So if we do 8 years, and we're doing $10,000, we should have, it's going to grow like this. Okay, now what are we supposed to do? Try changing the range to print every 3 years instead of every 3 years. So if we do every 3 years, so let's say, see, it's going to be less. You're not compounding as often. So I'm going to do 9 years here just to see what 9 years looks like. 9 years, we go all the way up to 14,774. Can you remember that? 14,774. Now let's make this be 3 years, where I'm going to do range in years. Yes, I got to do 0, comma, years, comma, 3, I guess, or something like that. And then we got to do 3 times this, times 3. Times 3, I think. Yeah, that'll work. And so, okay, so it's, this is going to 9, and so I'm going to keep the same number of years here, and this goes to 14,774.55. Oh, let me do this. Okay, 15,208. 15,208, year 9. 15,208. 15, yes, 15,513. So, so in year 9, if we compound it every year, we get this amount. If we only compound every 3 years, then we get a little bit less. This is supposed to show you, I guess. All right, what sequence is generated by range 7 and be going from 0 to 6? This one here. All right. 2, 3, and 4. Range function. Every integer from 0 to 500. Write the simplest range function that generates the appropriate sequence of integers. Every integer from 0 to 500. Well, are we including 500? Because if we're including 500, it's going to be range of 501. If we're including 500, let's see what the answer is. Oh yes, well, I'm pretty smart on it. Every integer from 10 to 20. So range 10, comma 21. No. Every second integer from 10 to 20. I don't know. Is that I don't know. 10 to, I assume we're going to include 20, so I'm going to put 21 here, and I'm going to put 2. See what happens. Ah, yes. Okay. Well, anyway, you can do those. All right. I'll do one of these. How are we doing here on time? Okay, good. Let's see. Start. 4i in the range of 3. Range of 3 would be 0, 1, and 2. So what am I supposed to print out here? I'm supposed to print out 0 and 1. Oops. And 1 and 2. Space. Methinks. Yeah. All right. Okay, you can do the next one. What's next? Oh, and now we're going to talk difference between whiles and fors. You can always, there isn't anything that you can do with a for loop that you cannot do with a while loop. But there's stuff you can do with a while loop that you cannot do with a for loop. Both for loops and while loops can be used to count a specific number of loop iterations. A for loop combined with range is generally preferred over while loops, since loops are less likely to become stuck in an infinite loop situation. A programmer may easily forget. Well. Don't worry, I don't have COVID. I don't go anywhere. I stay home all the time. All right, so here we're talking about that. Sometimes you forget that. a for loop when the number of iterations is computable before entering the loop. But if the number of iterations is not computable before entering the loop, then you generally would use a while loop. And it's like if you're looping until a sentinel is reached, you have to use a while loop. If you're reading a file and you're going to read until you get to the end of the file, that'd be a while loop. These are not hard rules, just general guidelines. Iterate as long as the user entered string C. Iterate as long as the user entered string C is not Q. Well, that'd be a while loop, I guess. So you'd have something like this. Iterate until the values of X and Y are equal, where X and Y are changed in the loop body. Well, that'd be a while also. This one's pretty obvious. Okay, you can have nested loops. Of course, you can have nested loops. So when you count up how many iterations the inner loop is, when you count how many iterations the inner loop takes, it's the number of iterations. It's the number of iterations that this generates times the number of iterations that this generates. So here's an example of where generating all of the two-letter domain names, .com domain names, which they're all obviously taken. These were all taken by 1994. They were all taken, I bet. So we see that the outer loop is the first letter because we start with an outer loop of A. The outer loop starts with A, and then we loop through this inner loop where the second letter goes from A to Z, and it's not until the second letter reaches Z do we drop out and go to the next outer loop letter. See, this is the outer loop. This is the body of the outer loop, and so first this executes, then this thing executes, and then when that's done executing, then this executes. So this thing increments to the first letter to the next letter, and it keeps on incrementing until it hits Z. So that's why we see the A stays the same all the way. Well, the second letter iterates from A to Z, and then it goes to B, and then it starts over again, A to Z. So outer loops and inner loops. So what is this? Modify the program to include two-letter.com names, or the second letter can be a letter or a number. Well, the second letter can be a letter or a number. Well, so sure. But what happens when I run this now? These are all just two-letter domain names all the way down to 26 times 26, whatever that is. So I want to make it be in numbers. Well, I'm just going to do this. I'm going to do this. For I in range 10, this. Where this is I. That work? See, this is a, yeah, let's see if this works. Run. Yes, I think it's working. See, there's A0, AZ, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then B all the way up to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. C. Oh, yep. Okay. Very good. Cool. All right. What's next? Nested loop example. Okay. So there's a loop inside here. And this is the outer loop, the body of the outer loop. So what does this do? It looks like it's got a sentinel of -1. Okay, so for however many, for what the number is, that's how many asterisks that's how many asterisks are printed. Run the program below to observe the. Okay, so oh, somebody types in a 5, and see, this is, I'm gonna just quick. And what am I supposed to do? Modify the program to print 1 asterisk per 5 units. Sure, 1 asterisk per 5 units. Range of num. Well, all right. How about if I 0, comma num, comma 5? Do it. Does not. Maybe 40. I'm going to put 40. 40. All right, I guess. Nice. Okay. Let's check our understanding. I'll do this one. What is the output of the following code? C, well, C1 is less than B, B. Okay, this increments C2 from A to C, and this increments C1. This doesn't even increment C1 because C1 is the next one after that is B, and if it's got to be less than B. So so I would say that it's A. It's going to do A, B, A, C is what I think. A space A, B space A, C space. I think that's what the answer is. It is. Okay, very good. So you can do these. What is the output of the following code? I1 goes, okay, it increments by 10. So it goes 1 and 11. So it's the I1 is going to be 1, and then the next time I1 is going to be 11. Okay. I2, on the other hand, is going to be, first time it's going to be 3, next time it's going to be 6, and once it's 9, it's over. I mean, when it reaches 9, it's over. Oh no, it'll equal. So it'll 3, 6, and 9 are valid here, but this is just 1 and 11. So what am I supposed to print out? 1, 3, space 1, 6, space 1, 9, space 11, 3, space 11, 6, space 11, 9. Space. All right, yep, that's what it is. Okay, so let's do a challenge activity here. Nested loops print seats. Okay, so given num rows and num columns, those are going to be inputs. Print a list of all the seats in a theater. Rows are numbered columns are lettered, such as A1 or 3E. Print a space after each seat. Okay. All right. Well, this looks like a job for this one. So first I'm going to enter the rows, enter rows, and this is going to be enter columns. This is going to be rows. Rows are numbered, columns are lettered. So I'm going to make this be enter row, enter well, it's okay. So rows are numbers, columns are letters. So I'm going to need to declare more variables, huh? All right. Well, So I'm going to have a for R for rows in range of num rows. Okay. And then I'm going to have to do, oh, I got to do this changing to a letter thing. Changing to a letter. How did we do that again? Here we go. This thing. Yeah, that's how you make. It's that. It's something that looks like that. So for column in range of num calls, I'm going to say letter equals, no, it's something to do with this. What is this now? It's the character of the ord of, yes, that's what it is. It's the character of the ord. What's that? Oh, letter. No, C. Oh, no, not ord C. It's going to be character of the ord of A. The ord of A plus C. That's what's going to be. So we take the ordinate, the ordinal value of A, which is like I don't know, 690 or something. I don't know what it is. It's ASCII. It is what's this? Ooh, this looks terrible. Where is A? A is better one here. A is capital A is decimal 65. So decimal 65. That's what it starts at. So the ord of capital A is 65, and then we add this to it. It's going to start out at 0, so it'll start out at A, and then this will be what the letter will be. And so we want to print out print. Oh, does it tell me how to do it? Oh. Doesn't it give me some hints on how to print that? Okay, we'll go back to one of these things. Here, this. Print this. Copy this. Getting close. I want to do something like this. And so I'm going to print, the number's fine. So I can just print the number R. and then this should be letter, the letter, like that. Let's see, save, and I'm gonna do 2 and 3. Let's see what 2 and 3 does. Rows 2, columns 3, 0, A, 0, B, 0, C, 1A, 1B, 1C. I don't think that that's right. But I think you can fix it. You can fix this. Okay? All right, you know enough to do that one. So what's next? It's 1226. Developing programs incrementally. Okay, so you know, now I think now might be a good time to, let's see what is let's see. Okay, I've got 4 minutes. I'll talk a little bit about this. Okay, so when we start to make bigger programs, you know, you aren't going to be able just to sit down and start writing code and you know, from the top to the bottom. You have to do this. You develop techniques for breaking problems down into smaller and smaller chunks. And that's this incremental programming is sort of a technique for that. And so let's say you're writing a program to print out, to print out where somebody enters in a phone number and it's going to print out, you know how it used to be where, you know, you would, to the letter, you know, the letters on your phone, you know, you can like my phone number is 808-371-7424. But you know, my first name is Rich, and so it's actually 808-371 Rich, R-I-C-H. You know, I did that back when I got my phone. So that's what this is about. Okay, so you're able to enter in a phone number, and then it's going to print out, you know, this. And so the way we do it here, this goes through it. We start out real simple. First, we just read in the phone number, make sure we can read in the phone number, and then we print this out. And this is the phone. This is what we read in. Oh, I guess this translates from the letters to the numbers. Really. Oh, this makes. What does this do? Oh, I see. This one doesn't work yet. Okay, we're supposed to write this from here. Okay, well it's 1228. We can fool around with this later. Do they give me the solution to this? They sort of do. Okay, well anyway, I'll talk a little bit more about incremental programming next time. This is ITS128. So it's going to become more and more important as you go along, but it's sort of a natural talent that you sort of gain through practice. All right. So anyway, I've carried you all the way through 5.8. Did a bunch of challenge exercises. Next time we'll finish it up. I'll take a little bit of time to go over these other constructs, which we really don't use very often at all, but they are there. And then I'll buzz through a few of these you know, labs down here, and that will be. We are in October 8th, so we are in here. Okay, good. So next week I'll probably schedule 2 classes in the first part of the week to finish up the labs here, and then next week, second time next week, we'll start with the functions.